Let's take a look at Chapter 3. The first topic is quadratic functions and applications. Now, it's referring to vertex form. Not all books call it vertex form. Some books call it standard form. So standard form or vertex form looks like this. We got f of x is equal to a times x minus h squared plus k. And if you have it in that form, you can easily identify your vertex. Your vertex is hk. Your axis symmetry is x equals h. Now, if a is greater than 0, it's positive. That means your graph's going to open up like this, which means you'll have a min, you'll have a low point. If a is less than 0, if a is negative, your graph's going to open down. And that means you'll have a max. You won't have both. So your min or your max is going to occur at k. Or it equals to k, I should say. Okay, so if we looked at an example, we got f of x is equal to a, which we'll put into, times x minus 1 squared. Actually, we'll put that plus 1. And then plus 3. So we have this this form right here. Well, if we identify all our different letters, whatever number's in front here is our a, so a is 2. Whatever number's inside of our x is going to be our h, but it'll be opposite sign. That's a positive 1, so h will be a negative 1. And then whatever number's here at the end will be our k, so k is 3. Why do we flip the sign on this? Notice our formula has a minus in there. Whenever you have a minus or a negative in your formula, it always flips the sign. Well, now that we have that, our vertex is hk, which is going to be negative 1, 3. Now our axis symmetry is x equals h, and h was negative 1, so x is equal to negative 1. So this is our vertex, this is our axis symmetry. Now a is 2. Since a is positive, that means our graph opens up. And we said if our graph opens up, that means we're going to have a min. So our min is going to equal to k, and k was 3. Now let's actually take a look at the graphing that. If you're doing it by hand, then go put your vertex in first. You got negative 1, 3, which is right here. You know your graph opens up because a is positive, so it doesn't have any x-intercept. We don't even need to try to find the x-intercept, but it does have a y-intercept. Now to find our y-intercept, you always plug 0 in for the other variable. Remember, f of x is the same as y. So we got y is equal to 2 times, and we'll put 0 in for x. So we got 0 plus 1 squared plus 3. 0 plus 1 is 1, 1 squared is 1, times 2 is 2, plus 3 is 5. So our y-intercept occurs at 5. Now that I have that, I know it's got a U-shaped graph to it. I can graph it this way. Now axis symmetry, x equals negative 1. Oh, I didn't draw it very well there. Here's our axis symmetry. What the axis symmetry says is you can take this right side of the graph and you can reflect it, flip it across that line, and it'll land exactly on this piece. So what that allows you to do is once you have one side, you can just flip it over and you'll have your other side of your graph. Now if we plug this into the calculator, So it comes up. There we go. Took a while. We press y equals, we press clear. And then I'll do 2, beginning parentheses, x plus 1, closing parentheses squared, plus 3, and then graph. And that'll give you your graph. So pretty easy to do by hand, but also even easier on a calculator. They're not always so easy to do by hand. Okay. Now this second topic says write f of x equal ax squared plus bx plus c in vertex form. That would be, for example, if I had ax squared plus bx plus c, and I want to transform that to a times x minus h squared plus k. That's what they're referring to. For example, if I have f of x is equal to 2x squared plus 4x plus 1. And we want to rewrite that in our vertex form. That's called general form. Though those different books have different names for it. Well, first thing we have to do, let me bring up Word so I can type this out. And okay, let me share that. So, not that you need to see me up in the right-hand corner, but okay. So this is going from this is quadratic function, converting from general form to vertex form. Step 1, group the x's together and the number by itself. Okay, so step 1. Got f of x equal to 2x squared plus 4x plus 1. When I say group the x's together, I'm talking about terms that have x's in them. So we're going to group those two together, and I'll group this one together. I'm going to write this in terms of x's, but you can have any variable. We want to factor out the number in front of the squared, the coefficient. So we're going to factor out a 2, and that gives us x squared plus 2x plus 1. And then we want to complete the square on what is inside the parentheses. And how we do that is we take the number in front of the x, multiply it by 1/2, square it, and then add and subtract that number right inside the parentheses. Okay, so take the number in front of the x, multiply by 1/2, square it, then add and subtract that number right inside the parentheses. Well, the number that's in front of our x is a 2, so I'm going to put it over here on the side. You always multiply times a half and you always square it. Only thing that changes is whatever number's in front of this x. 2 times a half is 1, and 1 squared is 1. So then, I said we're going to add and subtract that number right inside the parentheses. So we're going to have x squared plus 2x plus 1 minus 1, and then the plus 1 at the end. Carries down. Now that may seem strange. It's like, why would you do that? We haven't changed this value at all. 1 minus 1 is 0, so it's still equal to the same value as the previous line. Group the first 3 terms together and the last term by itself inside the parentheses. Now what I mean by that, we got f of x is equal to 2, then we got x squared plus 2x plus 1 minus 1 plus 1. So I'm grouping these first 3 terms together and grouping the last one by itself. Well then, I'm going to factor the first 3 terms. Actually, I'm getting off of my numbering, aren't I? Those are b's and so forth. That's 3a, 3b, and 3c. Term by itself. Okay, that's 3b. And then 3c. Okay, so this factors as 2 times x plus 1 squared minus 1 plus 1. Now I'm not some kind of factoring genius or anything. Whatever number's right here, right before you squared, sign included, is always what goes right here. Since this is a positive 1, we put a positive 1 there. Now that's completing the square part. So now we're at step 4. Step 4 is to multiply the number in front. Actually, that's the number we factored out in factor number in front of the square root in step 2. Multiply a number in front from step 2 by both groups. What I mean by that is we're going to take this 2 that's out in front here, we'll multiply times this first group and by this second group. Because remember, we group these together, we group this together. So that's going to give us f of x equal to 2 times x plus 1 squared plus 2 times negative 1 plus 1. And that's going to give us f of x equal to 2 times x plus 1 squared minus 2 plus 1. And then step 5 is combine numbers. So we got f of x is equal to 2 times x plus 1 squared, and negative 2 plus 1 gives us negative 1. And that's our vertex form. So you can see it's not a real simple process to do that. Okay, create quadratic models using regression. Let's talk about that briefly. Let me clear this off, actually. This is one I really wanted to make sure I covered because I'm pretty sure I don't have any YouTube video on how to do this out there. Okay. Let's say I got this data. Let's see, -2, -1, 0, 1, 2, and I got say this is 50, 20, 4, 17, and 41. And I want to come up with a quadratic model that goes with this. Well, first thing I'm going to do is put the x values in L1 and the y values in L2. So on my calculator, I'm going to press my Stat button, do Enter on Edit, and if you already have numbers here, you can delete it just by pressing your Delete key. So I'll press my Delete key, I'll delete the number that's highlighted, and I can keep doing that to delete the numbers out. There's a quicker way to do that, but this is a safe way. Okay, so I got -2, -1, 0, 1, and 2. And then I got 50, 20, 4, 17, and 41. Now you should have your calculator set this way from before, but we'll do a second mode to exit out, and we'll go into our catalog. You only have to do this one time. So if I do second 0, and that pushes button looks like x and -1. That's actually the inverse button. It'll take you down to the D's. And we're looking for diagnostic on. Now once you find diagnostic on, you press Enter twice. Okay. Now if we go to Stat, Calc, and we want to choose number 5, Quadratic Regression. Press Enter on it, and then you press Enter again. It assumes L1 and L2. And we get this. Now the R squared. The closer that is to a +1, the better your model is. This is 0.988, which isn't too bad, and it shouldn't be because I made the numbers up, but I made it so they followed a quadratic pattern, more or less. So our model, what we're going to do is plug in the A, B, and C into this top equation. So top equation says y is equal to ax squared plus bx plus c. And I'll take it 2 decimal places, but you take it to whatever they'd say. Y is equal to 9.79 x squared minus 2.1x plus 6.83. And that would be our quadratic regression model. Means we could use that to do predictions. Okay. Now the in behavior, section 6.2. Let me clear that off. And I won't show all these topics, so. Like intermediate value theorem, I'll have you read that in the book. Sketch a polynomial function. Again, you read that in the book. But I'm going to focus on these first two. Now we have some definitions. We have a term, which is a number times a variable, and I'll put an S on there to indicate you can have more than one, or a variable times a variable. And again, I'll put an S on there to indicate you can have more than one. Now this is a simplistic definition. You'll find a more complex one in the book, but this will get us going with what we need. We have the coefficient. This is the number in front of the term in terms of multiplication. For example, if we had 3x, then our coefficient would equal to 3. Now we have something called standard form. This is where your terms in a polynomial are arranged from largest power down to the smallest power. So that would be your standard form. Now when it's in standard form, your leading term is the first term when the polynomial is in standard form. The leading coefficient is the coefficient of the leading term. And we have a degree, which is our largest power of x. Now we know it's a little bit more than that, but that's the definition we'll go with. Sorry, I had to get a drink. Okay. This next topic is something called the leading coefficient test. This phone ringing. Okay. Now we got a positive coefficient. We got a negative coefficient. Those are two possibilities. We got an even degree, and we got an odd degree. Now this tells you the end behavior of your graphs. What's it doing clear to the left, what's it doing clear to the right. Doesn't tell us anything about what's happening in the middle. If you got a positive coefficient and even degree, then it's up to the left and it's up to the right. If you got an even degree and negative coefficient, it's down to the left, down to the right. If you got an odd degree and positive coefficient, then it's down to the left and it's up to the right. If you got a negative coefficient and odd degree, then it's up to the left, down to the right. Okay, so let's make up a problem, and we're trying to determine the end behavior. Let's say we got f of x is equal to 4x to the fourth minus 7x plus 2. And again, the end behavior is what we're wanting. The leading coefficient test is based around the first term, leading term. If I look at this, I see the coefficient is 4 and it's positive. So we've got a positive coefficient, and our degree is always going to be the power on our leading term, largest power of x. This is an even degree. So if I look at positive coefficient and even degree where they intersect, it says up to the left, up to the right, and that would be our answer. So up to the left, up to the right. Now some books like to use a little sign, or not a sign chart, but a little chart for this with pictures. And they'll give you something that looks like this. Up to the left, up to the right. This helps you if you're graphing it by hand. If you watch the YouTube videos I put out there, you'll see the full explanation how to do it by hand. It helps you on the calculator too. If you go and graph this, and you see this right here for your graph. And you're looking at your standard viewing window, and you think, okay, that's my graph, and I could have made that a little smoother there, but you get the idea. There. If you look at this and you think, okay, that's what my graph looks like. That's what the calculator says. But if you look at the leading coefficient test, you can see it's supposed to go up to the left, not down to the left. What that tells us is at some point this is going to turn back around and come back up. It doesn't really tell us anything about what's happening in the middle, but it tells us what's it doing as it goes clear to the left, what's it doing as it goes clear to the right. So it's not a complete solution for determining how it loops, but it's a partial. If you go on and take calculus, that's where you'll learn about mins and maxes, and you'll find out increasing, decreasing, and how to get the true picture. Okay, let me clean that off. And let's review. We've got x squared minus 5x plus 6 equal to 0. And we want to factor these. Got x minus 2, x minus 3 is equal to 0. So we factored. That's a verb, I believe. Now these are called factors. Nouns, maybe. Then we set each factor equal to 0. So we set x minus 2 equal to 0. We'll set x minus 3 equal to 0. And solve these. And we get x equals 2 and x is equal to 3. Now these are our answers. They're also called our zeros. And they're also called our roots. Now keep this in mind as we look at some of the topics this evening. Those become important in some of these other areas too. Okay. If I had this problem, f of x is equal to x minus 1 squared times x plus 3. And they're wanting us to identify the zeros and multiplicities of the zeros. So we're going to find this on this topic right here. Well, we found zeros over here. It looks like to find zeros, you're going to set it equal to 0 and solve it. Well, that's what we do. So we've got x minus 1 squared times x plus 3, set equal to 0. Now it's already factored, so I'll set each factor equal to 0. So I got x minus 1 equal to 0, and I got x plus 3 is equal to 0. Which gives us x equals 1 and x is equal to negative 3. These are our zeros. Multiplicity. Multiplicity is how many of them do you have? And it goes back to your powers here. Here we had the second power, which means that multiplicity is 2. Here, if I were to put it, it'd be a multiplicity of 1. So those would be our multiplicity. Although they don't touch upon it, but that tells us whether it touches or crosses. If your multiplicity is 2, if it's even, that means it touches. If it's 1, it's odd, that means it crosses. Why is this important? Well, if I'm graphing these by hand, and my zeros are negative 3, right there, and 1. Remember your zeros where it crosses the x-axis. At negative 3, it's going to cross, and at 1, it'll touch. If I know my leading coefficient and a degree, it's a little bit hidden here. What you have to do is if you take the first term here, x, raise it to the second power, that's x squared times x, that gives us x to the third. X to the third. That means that it's a positive coefficient and it's an odd degree. That means it's going down to the left and it's going up to the right. Okay, why is that important? Well, if I know it's going down and it crosses here and it won't cross or touch anywhere else because those are only intercepts. Remember, intercepts same as zeros. That means my graph's coming down like this. It's crossing, which means it has to cross the x-axis. At some point it has to turn around. Reason why is because it has to turn around so it can come down here and touch. Now what it'll do is come down and touch at a point and turn around and go back up. And you get this right here. So you can see that we have a primitive way to find out the rough shape of the graph. Now I don't know how far up it goes, so that part I'd have to maybe plot a point if I wanted to get any kind of precision. But it definitely gives you an idea, even if you're using a calculator, what should it generally look like. So if I go to y equals clear, and this is, let's see, x minus 1 squared, and then x plus 3. And if I press graph, that's what I come up with. And you see I'm not too far off. And I made this up out of my head, so you can see I don't have to know what the graph looks like to get a rough idea. And I guessed that it went up this high, and I wasn't too bad of a guess. Of course, these tick marks are different than what's on here, so this should actually go up a little higher, but we'll ignore that part. What told me that is I looked from where this crossed and where this touched, and exactly in the middle I figured by symmetry would be up here, the center. Then I just guesstimated where I thought it might go. Anyway, that's not only how to find the zeros in multiplicity, but also what in the world are they used for. And you would see that in this part here, where sketch a polynomial function. Well, that's what I just did. Part of that would be then to find your intercepts, or plug in a few points also. Now let's take a look at 3.3. Division of polynomials and remainder and factor theorems. Okay. Clear this off. Okay, and let's take a look at long division. We've got x plus 3. Then we got x squared minus 7x plus 1. What we want to do is we want to look at the first term of each to decide what goes up on top. And it's never how close, it's always exact. So you ask yourself, what times x gives you x squared? And that'd be x. Now whatever we put up on top, we're going to multiply by what's out in front. So I'm going to take x times x plus 3. And that gives us x squared plus 3x. Now we're going to subtract that, which means we're going to flip signs. So the x squared becomes negative, the positive 3x becomes negative. X squared minus x squared drops away. Negative 7x minus 3x is negative 10x, and then we'll bring down the plus 1. And then we repeat the process. We look at the first term of each side, what goes up on top. You ask yourself what times x gives you negative 10x, and that'd be negative 10. Now whatever we put up on top, we're going to multiply by what's out in front. So take negative 10 times x plus 3, which gives us negative 10x minus 30. Now we're going to subtract that line, which means flip signs. So this negative becomes positive, this negative 30 becomes positive. Negative 10x plus 10x drops away. 1 plus 30 is 31. Now, the degree of this 31 is 0. Degree is the largest power of x. The degree of x plus 3 is 1. When the degree of whatever you have down here is less than what you're dividing by, this is always a remainder, no matter what it looks like. So we'll take our remainder and put it over what we're dividing by, and that would be our answer. I'm not going to actually work this problem. but I want to talk about the setup. In order to do long division, two things have to be true. What's out in front and what's underneath have to be in standard form. So this one I'd rewrite as 7x plus 1. This one I'd rewrite as x squared plus 2x minus 3. Now I want to say in standard form, your terms are arranged from largest power down to smallest. So x, no x, x squared, x, no x. So this is in standard form. If I had this right here, not only do they have to be in standard form, but you have to put in 0 placeholders for any missing powers. For example, this isn't in standard form. The x to the fourth needs to go first. Now we're missing the x to the third, so I have to put a 0 placeholder there. So plus 0x to the third, plus x squared, we're missing the x, so I'll put a 0x, a 0 placeholder, and then plus 1. And then you go through and do your steps. So those have to be true whenever you're doing long division. What you'll find is that if it's not in standard form and you don't put 0 placeholders, it's very challenging, if not impossible, to get the correct answer. Now synthetic division. If I have x to the third minus 7x plus 2, and I want to divide that by x minus 2. Using synthetic division. First step, we take what we're dividing by, which is x minus 2. We set it equal to 0 and want to solve it. So that gives us x equals 2. Now step 2. We want to take the number we just found, we want to put in a box in the upper left-hand corner. So again, whatever you have here, you can put in a box. And then we want to identify our largest power of x. Our largest power of x is x to the third, so real small across the top, I write x to the third, x squared x, and no x. You do not want to write these large at all, just very small, as small as you can get. Then we're going to write down the numbers in front of each one of them. The number that's in front of our x to the third is the invisible 1. There's a 1 here. In front of our x squared, there is no x squared, so that means there's a 0 there. Number in front of our x is a negative 7, so put negative 7 there. And our no x, our constant term, is 2. Now we're going to go through a series of adding, multiplying over and over until we're done. And we'll talk about how you know when you're done. Okay, so first thing we're going to do is add. So we start with our first column here. We got 1 plus nothing is 1. It'll always work that way. Since there's nothing right here, you'll always just bring this number straight down. Then we're going to multiply. You always multiply by a number up in a box by the number you just put down here. So we got 2 times 1 is 2, and we'll put it here. That's our multiply. Now we're going to add. 0 plus 2 is 2. Then we're going to multiply. You take the number in the box times the number we just put down here. 2 times 2 is 4. And then we're going to add. Negative 7 plus 4 is negative 3. Then we're going to multiply. You always multiply by a number in the box, by a number you put down here. 2 times negative 3 is negative 6. And then we want to add. 2 minus 6 is negative 4. Now, we know we're done because there's no more columns to work with. So once you reach your far right column, you got no more columns, then you're done. Now this was x to the third. Straight down below it will be 1 degree lower. So this will be x squared. This will be x. This will be no x. And this is a remainder. So we're going to have x squared plus 2x minus 3, and then we'll take our remainder and we're going to put it over what we're dividing by, which is the x minus 2. And that's our answer. Now that's our synthetic division. They're talking about the remainder and factor theorems. And I'm going to talk about the factor theorem in the next section. And the remainder theorem, you can watch a YouTube video on there. It's just not real challenging or anything. The zeros with polynomials, though, is kind of a challenging section. So let's talk about that. Let me clear this off. Grab a drink while it's clearing, I guess. Okay. And I'm gonna, these I can't make up out of my head, so I pulled up a PowerPoint from another class. And we got f of x is equal to x to the third minus 3x squared minus 18x plus 40. And instructions are to find all zeros. We talked about in the last section, to find all zeros, that's, you set it equal to 0. So we'll have x to the third minus 3x squared minus 18x plus 40 equal to 0. Now our fundamental theorem of algebra, among other things, says that your largest power tells you how many answers you're going to have. Since our degree is 3, that means we're going to have 3 answers. Now we're going to use a calculator to find as many answers as we can. Specifically, we're going to be using the intersect method. So the intersect. So let's write down the steps for that. So finding the zeros using the TI-8384. Step 1, put a polynomial on y1, 0 on y2. Step 2, we're going to do a second trace. We're going to choose intersect. We're going to enter on first curve. We're going to enter on second curve. Then we'll input a guess close to our answer and press enter. And then 3. If we have decimals, we're going to do a second mode to exit out, and then we'll do math, enter, enter. Okay, so let's take a look at this problem we just discussed. Okay, here it is. Step 1. We're going to put our polynomial y1, 0, and y2. So we'll go to y equals, if you're not already there. Press clear to clear out wherever's not line. And then we've got x caret 3, x to the third, minus 3x squared, minus 18x, plus 40. And then I'm going to down arrow to y2 and put 0 on y2. This process does not work if you don't have 0 on y2. Now we're at step 2. We're going to do second trace and choose intersect. So do second trace. We want to choose intersect. You can down arrow to it and press enter on it, or simply press the 5 that's in front of it. That'll do the down arrow and enter for you. Then I tell you to do enter on first curve. You'll notice it comes up in the lower left-hand corner saying first curve question mark. It's asking you for the first curve. You don't do anything exciting, you just simply press enter. Then I tell you to do an enter on the second curve. Again, notice it's asking us for second curve question mark, so you simply do enter again. Now when I say input a guess close to our answer and press enter, our answer is where it crosses the x-axis. And you see, look at a little blown up picture of this. Looks like it's crossing at -4. So let me put -5 in for my guess. So I'll type in -5 and press enter. And what it'll do is it'll find the answer closest to your guess. So it comes back and tells us the intersection is x equals -4. So that's our first answer. Now our answer is wherever it crosses the x-axis. And I see it crosses in 2 other places, plus the fundamental theorem of algebra said I had to have 3 answers. So I want to go through the process again. So I'll do second trace, choose 5 for intersect. I'm going to find this next one that looks like 2. So I do enter on first curve, enter on second curve. Now for your guess, you don't have to input an answer close to, or guess, close to where the answer is. You can actually input what you think the answer is. I think it's 2, so let me go ahead and put 2 in. So I'll do 2 and then enter. And it'll tell you, it comes back and tells us, yes indeed, the intersection is x equals 2. We got another one. It's like 5. If I do second trace, choose 5 for intersect, enter on first curve, enter on second curve. There's a third way you can do the guess. You can input a value close to it, you can input what you think the answer is, or you can use your arrow keys. Notice my flashing cursor is right here. I can do my right arrow key to move my mouse over close to the one I'm trying to find. Now once it's over close to the one you're trying to find, then you can press enter on that. And it comes back and tells us that our answer is x equals 5. So that's our third answer. Now that technique is useful if you're going on to calculus or trig. Sometimes you do not know what those tick marks represent. So you have to use your arrow keys instead of typing in what you think the answer is. Okay, let's take a look. I won't look at one with a fraction. If you get a decimal, you just simply have to do a second mode to exit out, and then you try to do math to enter. We're going to see that technique in some of these other ones anyway. So let's get down to this example. You got f of x is equal to x to the third minus 4x squared plus 9x minus 10. Now again, we're trying to find a 0, so we'll set it equal to 0. So we got x to the third minus 4x squared plus 9x minus 10 equal to 0. The largest power is 3, which means we're going to have 3 answers in the fundamental theorem of algebra. Let's go to the calculator and see what the calculator gives us for answers. Okay, so I'm going to go to my y equals, and I'll put in, actually I guess I can leave that up there. So we got x caret 3 minus 4x squared. If you got one of the newer calculators, the newer T84s, you have to, after you do the 3, you have to do a right arrow key to get out of the exponent mode. Plus 9x minus 10. And you should already still have 0 on y2. That doesn't hurt anything, leave it there from now on. Now if we do second trace, choose intersect. Looks like it crosses at one place. Looks like 2. Let's verify that. Enter on first curve, enter on second curve, and I'll put 2 in for the guess. And it is 2. Well, that's no good. We know we had to have 3 answers. Calculator only gave us 1. Well, what we do is we take the answer it gives us, and we're going to plug it into synthetic division. Okay, so put the 2 in the upper left-hand corner in the box. Remember, this was x to the third, this is x squared, this is x, and this is no x. So we're going to add. 1 plus nothing is 1. We're going to multiply. You always multiply by a number in a box, but I'm going to put down here. 2 times 1 is 2. We want to add. Negative 4 plus 2 is negative 2. we want to multiply it. 2 times negative 2 is negative 4. 9 minus 4 is 5. 2 times 5 is 10. Negative 10 plus 10 is 0. Last section I said we were going to ignore it for the time being. We'll talk about it later. And what I said we'd ignore is the factor theorem. Although it's written more math-wise than what I'm going to write, I'm writing from a practical standpoint. How can you use it to help solve problems? What this says, if you're in the middle of this process, if your remainder is equal to 0, then you found an answer. So then you found an answer. Now remember, another name for answer is 0. So what that tells us, since we came up with a zeros remainder here, it means this number in this box is our first answer. X equals 2. Now that's no big surprise. Calculator told us it was an answer. So you better get 0 as a remainder. But that's what the factor theorem says. How does that help us? Well, this is x to the third. We're now down to x squared. This is x, and this is no x. So if I write down what I have left, I have x squared minus 2x plus 5 is equal to 0. Why do I set it equal to 0? We're finding zeros. Anytime you're finding zeros, you're constantly setting it equals 0. Now this is not factor, but I can use quadratic formula. Now a is going to be whatever number's in front of our x squared, so a is 1. B is going to be whatever number's in front of our x, which is negative 2, and C will be a number at the end, which is 5. Quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay. So we're going to have negative 2 plus or minus square root of negative 2 squared minus 4 times a, which is 1, times c, which is 5, all over 2a, so 2 times 1. Negative gives us positive, so we've got 2 plus or minus square root. Negative 2 squared is 4, minus 4 times 1 times 5 is 20, over 2. So that gives us 2 plus or minus square root of negative 16 over 2. If you remember from the complex numbers, the negative 16 inside of a square root, negative comes as an I, and 4 times 4 is 16, so that gives us 4i. Now since we have an imaginary part, I want to split this up. Real part, 2 over 2, plus or minus, and then imaginary part, 4 over 2, with an I beside it. So we have them separate. So 2 divided by 2 is 1, plus or minus, 4 divided by 2 is 2, so we got 2i. Now the fundamental theorem of algebra says you're going to have 3 answers if you get degree is 3. It doesn't say they're all going to be real. So here we came up with imaginary answers. Now if you have imaginary answers, they always come in pairs. Some books refer to this as a conjugate theorem. Conjugate pair theorems, I've heard it referred to that way. Different ways of writing it. But it means that we have 1 plus 2i, we'll automatically have 1 minus 2i. If we have a 5i, we'll automatically have a negative 5i. So those are pairs. Okay, let me clear that off. Now I'm going to show you one where you use the square root property. Let's see, I'm pretty sure there's another quadratic formula. I think this one is a square root property. So we got x to the fourth minus x to the third plus 3x squared minus 9x minus 54 equal to 0. Now our largest power, our degree, is 4, which means we're going to have 4 answers. So let's plug this in and see what we get. So y equals clear. X caret 4, do a right arrow key to get out of the exponent if you got one of those newer calculators. Minus x caret 3, again do the right arrow key to get out of the exponent mode if you got one of the newer ones. Plus 3x squared. Minus 9x. Minus 54. And we have 0 on y2. So now do second trace and choose intersect. Now our answer is going to be where it crosses the x-axis. That looks like an answer. This is another one. Looks like -2 and 3. I could go through and verify that. So I do enter on first curve, enter on second curve, and I'll put in -2 in this one. And indeed is -2. Do a second trace, choose intersect, enter on first curve, enter on second curve, and we'll put 3 in for the guess. And it comes back and tells us 3. Now those are pretty obvious. They were going straight through there. But -2 and 3 is what we came up with. We said we needed 4 answers. We only found 2 via the calculator. Well, that's okay. We can work with that. So let's plug that in. We'll put -2 in. Okay, so I'm going, and this is x to the 4th. So I'm going to add, multiply, add, multiply, add, multiply, add, multiply. I assume you know how to do synthetic division. You have to be good at synthetic division for this process. Remember what that 0 means. As a remainder, that means you found an answer. So our first answer is -2. No big surprise, calculator told us that was going to be an answer. Now we started off at x to the 4th. We're now down to x to the 3rd. And we want to plug in our second answer. So we'll plug in 3. So I'm going to add, multiply, add, multiply, add, multiply, add. Now notice we get another 0. That means we found our second answer. So x equals 3 is our second answer. And this went from x to the 3rd, and we're now down to x squared. And this would be x, and this would be no x. Now anytime you have a 0, you can just drop that off. So this gives us x squared plus 9 equal to 0. Now once you get it down to the quadratic level, you can use quadratic formula, the square root property, or some other technique to factor it. So here, I'm taking 9 over. Whenever your middle term is missing, you can use the square root property. Now we have something squared equal to something else. So square root property says we drop our squared and we put a plus or minus square root on the other side, which gives us x is equal to plus or minus 3i. Okay, so we came up with 2 answers here. Then we through the synthetic division process that helped us to find our other 2 answers, because that plus or minus means there's 2 answers there. Now sometimes, I will tell you this, if you're going through this and you have decimals that will not convert to fractions, then what you'll find is in this process, as you go through this, you're probably going to end up with some kind of radical answer. So don't panic if you have a decimal that will not change to a fraction. Take what you do find, plug it in to the synthetic division process, and then find it that way. Okay. Now if you're doing these by hand, well, let me show one of them by hand. Not a very pretty process. Okay, so let's take a look at this one. We've got x to the 3rd minus 3x squared minus 18x plus 40 equal to 0. And some of these techniques that we don't have time really to cover, where it's talking about Descartes' rule of signs, upper and lower bounds, those help in this process. to list all the possible rational zeros. And that's what this says. Apply the rational zero theorem. That's all of your possible answers. Specifically, rational means you can write it in fraction form. We identify our number at the end. Number at the end is going to be our P, and we identify the number at the beginning, which will be our Q. So P is going to be 40, and Q is going to be 1. Now we're going to write down all products give us 40. We got 1 times 40. We got 2 times 20. 4 times 10. And 5 times 8. Then we're going to write down all products that give us 1. Well, 1 times 1 is it. So we only have to put a 1 there. Now, there's something else that'll give us 40, though. A negative 1 times a negative 40 will give you a positive 40. So how we account for all the signs is you just always put a plus or minus before any of these numbers. And then you don't have to worry about the signs. Same down here. Because a positive 1 times a positive 1 will give you 1, or a negative 1 times a negative 1 will give you a positive 1. Now all of our possible rational zeros is P over Q. So you can take each one of these values and put it over this Q. So I'm going to have 1 over 1. I'll have 2 over 1. I'll have 4 over 1. I'll have 5 over 1. 8 over 1. 10 over 1. 20 over 1. And 40 over 1. It's going to give us 1, 2, 4, 5, 8, 10, 20, and 40, all with a plus or minus in front of them. These are all of our possible answers that can be written in fraction form. Now I might be saying, well, they're not a fraction. What are you talking about? Well, remember, look at this previous step. 4 over 1. That's a fraction, isn't it? Specifically, you got an integer on top and an integer on the bottom. Okay, now that we have those, if I were to find these by hand, we have x to the third minus 3x squared minus 18x plus 40 equal to 0. What we do is we start with our first possible answer, and we're going to plug it in synthetic division. Okay. So we'll add, multiply, add, multiply, add, multiply, add. We're looking for zeros or remainder. Zeros or remainder tells us we found an answer. That doesn't work. So let's plug in negative 1. So 1, negative 3, negative 18, 40. So add, multiply, add, multiply, add, multiply, add. That doesn't work. Assuming I did all my adding and multiplying correctly. I'm not always the greatest on that. Some of my basic math skills sometimes fails. I'll try negative 2. So add, multiply, add, multiply, add, multiply, add. That doesn't work. So then I'll try positive 2. So add, multiply, add, multiply, add. Let me check that. Add, multiply, add, multiply, add, multiply, add. Look what we found. We found a 0. That means we found an answer. That means our first answer is x equals 2. We're now down. This was x to the third. We're now down to x squared, and this is x, and this is no x. And that's our goal. If you're doing it by hand, get it down to the x squared level, and then you can use some kind of technique to solve it. Excuse me. So we got x squared minus x minus 20 equal to 0. This factor is using the PSD. This will be x minus 5 times x plus 4 equal to 0. Zero factor property, you set each one of these equal to 0. X minus 5 equal to 0, and x plus 4 is equal to 0. So we get x equals 5, and we get x is equal to negative 4. And we said we're going to have 3 answers, and we found all 3 answers via the by hand technique. Calculator simplifies that, as you can see. Especially if the first answer you find is over here, and you have to go through perhaps 12 different synthetic divisions to find the first one. Okay. Erasing this. Now let's talk about rational functions. And may not get past that, but I have videos out there for the rest of these, so you can watch those. Rational function. Real simply, a rational function is a function with a single fraction. For purposes of algebra, we're talking about variables in the denominator. Although technically, f of x is equal to 1/2 would be a rational function. It's a single fraction. You just don't see any of those that simple in these. Now, it gets down to asymptotes. So let's talk about a vertical asymptote. First, though, an asymptote is an invisible line that your graph will skim at some point. Get real close to it, but never touch it, never cross it. Note, it may cross the asymptote at a different place. When I say different, I'm talking about where it's not skimming. Now, that's only true of certain asymptotes. Like a vertical asymptote, for example, it can never cross it. But a horizontal asymptote, you'll find that there'll be problems where it'll cross it. So invisible line, your graph will skim. Well, our vertical asymptote. So finding the vertical asymptote, I'll put an S on there. Step 1, we want to factor the top, numerator, and factor the bottom, the denominator. Step 2, cancel if possible. And step 3, set the denominator equal to 0 and solve. So set our bottom equal to 0 and solve. Let's say we got f of x is equal to 1 over x plus 3. And we want to find the vertical asymptote. Step 1, factor the top, factor the bottom. Nothing to factor. Step 2, cancel if possible. There's nothing to cancel. Step 3, set your denominator equal to 0. So set x plus 3 equal to 0 and solve it. And we got x is equal to -3. I don't know much about this graph, but I know at -3, x equals -3 specifically, it's going to skim at some point. Now let's graph this in a graphing calculator just to see what in the world that's referring to. Anytime you have more than a single number or a single variable on top or bottom, you have to put parentheses around that part. So we'll put parentheses around the x plus 3. Okay, so go to y equals, clear. I'll do 1 divided by, beginning parentheses, x plus 3, closing parentheses, and then graph. Now notice here, as this graph is coming from both sides, coming from over here, here's x equals -3, it's going down forever, getting closer and closer to that line, but never touching it, never crossing it. Over here, as this coming here, it's going up forever, getting closer and closer, to -3, never touching it, never crossing it. So, you know, if I were to sketch a graph on this, based on what I'm seeing here, looks like it's, I don't draw very well. It's going to skim that forever, never touching it, never crossing it. Over here, it'll come up here, skimming this, but never touching it, never crossing it. Again, that's the idea of an asymptote. Now, you may have a little bit more challenging problem than that. For example, if we have f of x equal to x plus 2 over x squared plus 8x plus 12, and same instructions. Find the vertical asymptotes. Well, step 1, we factor the top, factor the bottom. So we got f of x is equal to x plus 2 over x plus 2 times x plus 6 Step 2, factor, or cancel. These x plus 2's cancel. So that gives us 1 over x plus 6. And then step 3, set your denominator equal to 0 and solve. So we got x plus 6 equal to 0 and solve it, and we get x equals -6. And that's our vertical asymptote. Don't know much about this graph, but I do know at -6 that it's going to be skimmed at some point. You know, I don't know, maybe the graph will come down here and skim it down that way. Maybe it'll come up here and skim it up like that. I don't know. But I do know it's going to skim it at some point. Okay, now that was our vertical asymptotes. So let me clear that off. Then we'll talk about our horizontal asymptotes. I've been referring to the top of the fraction, the numerator is top, the bottom of the fraction, the denominator is the bottom. I've been referring to the degree as your largest power of x. So for a horizontal asymptote, you got 3 cases. Case 1, the degree of the top is larger. That means there is no horizontal asymptote. Case 2, the degree of the bottom is larger. That means your horizontal asymptote is y is equal to 0. Case 3, the degrees are the same. And I'm going to put an example in here, and after I make it, the example, then I'll increase the size of it so you can actually see it. Okay, so we got f of x. Actually, that's probably not too bad. You can probably see me actually typing in that one. 5x to the third minus 7x plus 2 over 8 minus 4x to the third. Horizontal asymptote will be y is equal to 5 over -4. When I try to put this into words, it never comes out right. People get lost when I start talking about standard form, leading term, leading coefficient. But see how the degree of the top is 3, degree of the bottom is 3. It's a very simple idea, but put into words makes it complex. What we do to get to horizontal asymptote is we create a fraction. And we take the number off the front of the x to the largest power. So the x to the third is the largest power on top, so we take the 5 and put it on top. On the bottom we got x to the third, and the number in front of it is a -4, so put a -4 on the bottom. So our horizontal asymptote will be y is equal to -5/4. Okay, now let me make up a problem. And I think this is one we had just a little bit ago, or this type. We got this right here. Now, first off, just review our vertical asymptotes. We factor the top, factor the bottom, nothing will cancel. Or Nothing will factor, nothing can cancel. So we set our denominator equal to 0. Sorry, I see the time running out. So set the x minus 4 equal to 0, and that gives us x equals 4, which means my mouse is in the way, and I can't draw a straight line with the mouse in the way, that x equals 4 will be a vertical asymptote, like that. Now, horizontal asymptote, the degrees. The degree of the top, there's no x, so degree is 0. Degree of the bottom is 1. So my degree of the bottom is larger, which means my horizontal asymptote is y is equal to 0. Y is equal to 0 is actually the x-axis. Okay, so I know it's going to skim this line. It's going to skim this line. Now I can find one of my intercepts. I'm going to find the y-intercept. And we'll plug 0 in for the other variable. So to find the y-intercept, plug 0 in for x. So we're going to have y is equal to 1 over 0 minus 4, or y is equal to negative 1/4. So it means my y-intercept is right down here. Okay. Now there is no x-intercepts. What you do to find the x-intercepts is you set this equal to 0 and solve it. And basically it amounts to setting your numerator equal to 0 and solve it. Well, if you set 1 equal to 0, then there is none. And what I'm going to find is that this graph will skim going this way. It'll pass through here, and then it'll come and skim down here. And I'd have to plot a point to see this, but the graph should be up here. How do I know that? Well, I've just graphed a lot of these. But you could plot a point over here. You could use your calculator, definitely. But that's how you find your horizontal asymptote. Now our slant asymptote, or oblique, depending upon which book you look at. So slant asymptote, or oblique asymptote. Note, in order to have one of these, the degree of the top must be exactly 1 larger than the bottom. And what you do is you use long division and drop the remainder. Clear that off. So we got f of x is equal to x squared minus 7x plus 2 divided by x plus 1. Now if we went through, just review, our vertical asymptotes, you can't factor the top, so nothing will cancel. So you set your denominator equal to 0. So we got x plus 1 equal to 0, or x is equal to negative 1. Which means I got a vertical asymptote at x equals negative 1. Horizontal asymptote. Degree of the top is 2, degree of the bottom is 1. When the degree of the top is larger, there is none. So there's no horizontal asymptote. Our slant asymptote, or oblique, we're going to use long division. So it'll take x squared minus 7x plus 2 divided by x plus 1. Remember, we take a look at the first term of each, the x and the x squared, decide what goes up on top. You ask yourself what times x gives you x squared, and that'd be x. Then whatever we put up on top, we multiply by what's out in front. X times x is x squared. X times 1 is 1x, or x. Now we're going to subtract that line, which means flip signs. So it becomes negative, this becomes negative. X squared minus x squared drops away. Negative 7x minus x is negative 8x plus 2. And again, we look at the first term of each side, what to put up on top. X times negative 8 gives us negative 8x. Negative 8 times x is negative 8x. Negative 8 times 1 is negative 8. Flip signs. So this becomes positive, this becomes positive. Negative 8x plus 8x drops away. 2 plus 8 is 10. And that's our remainder, and we said our remainder drops away. So our slant asymptote will be y is equal to x minus 8. So I'm going to have a slant asymptote right here, like that. Now from there, we come up with our graph. And you can find intercepts. If I plug 0 in for x, for example, I'd find my y-intercept is 2. So here's my y-intercept. You know it skims here, so it's coming down skimming here. At some point turns around and comes up skims like that. And down here, I would find that it also has a piece that looks like that. So again, these are tools to help you graph these by hand. Now, we didn't get to all the topics. We've gotten into some of those, and then I got videos out there, like I say, for these last two sections. So I'll go ahead and stop the video, and then I'll answer any questions you have.